Welcome to Security Highlights. My name is Nathanael. I manage the Cybersecurity for DornerWorks. Today we're going to have a roundtable discussion regarding cybersecurity on IoT device development. We have some special guests that are with us. Ray Smith is an embedded software engineer. Michael Spoehr is a cloud solutions engineer. And Greg Nowak is a technology strategy leader for the IoT team at DornerWorks. Welcome, Ray, Mike, Greg. We hear a lot about IoT. Can one of you explain what the Internet of Things is and some history of how IoT security has evolved over the last few years?
Yeah, I can take that. IoT, or the Internet of Things, is kind of a generic name given to products that are connected to the outside world. So if you think about your home computer that has been connected to the internet for some time now, everyone's kind of familiar with your personal computer. And we're no strangers to the Windows updates that are happening. And that is the way to keep our personal computers kind of up to date on security. And that doesn't seem very strange to 99% of the people who are working on computers. Other devices that are connected to the internet are no different. So your toasters and refrigerators and washing machines and all the other things that are now internet connected also need to be updated. And so we have to have this concept of security applied to not only our personal computers, but also all of these other little gadgets that we have around. So I think that's becoming more and more commonplace and understood by the general public that yes, you need security, yes, you need to have these devices updated, and we need to provide a means of doing that.
Well, that's great. I see all these different news articles every week, and it's like this vacuum cleaner now is connected to the internet, or this microwave, and it's quite a lot of connected device. So thanks for that. I have a few general questions. I guess Ray and Michael, love to get some of your responses. How do we build security into our IoT device development?
If I had to sum it up, it would be to stay up to date on what the current security best practices are and follow them. So what that can look like is incorporating security into your product at every layer and level. Each component of the system, both on the cloud level if it's a connected product, and the device itself should be secure on all of its interfaces and even internally. So I'll talk a little bit about the cloud security. One of the most important aspects of cloud security is to implement a strong identity foundation. So that means every operator in the system is granted the least privilege possible to perform their function, and their identity is verified using strong authentication. And an operator in the system can take a form of an actual end user, an administrator, or the device itself. So it's not just devices or just the users. And it is important to adhere to least privilege because that minimizes the impact of security events. For example, let's say that a particular component of your cloud infrastructure has been compromised. If you had only granted that component the commands that it needed access to, then that limits the impact of someone having access to that component. You can also apply this principle to the human operators in your system, including your administrators, such as DBAs. Limiting their access is just as important. If a developer doesn't need access to a certain resource to perform their day-to-day activities, then they shouldn't have it. In some large systems, even administrators don't have access to the production database. So that can really limit the impact of someone being able to do something that shouldn't be done and compromise your system.
So kind of like isolated access. So
exactly, yeah.
Navigate through a system if they don't have the authority to do so.
Exactly. And the device should only be able to do the things it needs to do as well. So say you're shipping a device out to a customer and they could very well get into it and try to get the keys off of it or something like that. Even if they do that, they should only be able to interact with the system as that device and only impact things that would be related to that device. So for example, like say they got the keys that the device uses to talk to the cloud system off the device. They should only be able to update the status of their own device and not the status of any other device.
What are some other, ways of building security into the system?
Apply security at all layers. So commonly devices will connect to the system over like an HTTPS endpoint or some sort of other IoT connection. Commonly, those interfaces will be secured using encryption. So if it's an HTTPS endpoint, obviously that traffic is going to be encrypted using HTTPS. But those security practices shouldn't end at the cloud device interface. For example, if you have a device connecting to your cloud system over HTTPS, say it connects to a load balancer, then the load balancer distributes those requests to several components in your cloud system. The traffic between the load balancer and the cloud components, even though it's internal to your system, should also be encrypted and secured. That is important to protect your data both in transit and at rest. So you're protecting it at every level. While it's in transit, you're encrypting it and protecting it. And then you're also protecting it when it's at rest, say in a database. You can encrypt the database storage itself.
Is there any specific like encryption methods you guys prefer, or just as long as you have encryption, is that a good start?
Having encryption is obviously a good start, but you should be following the best practices and using the most secure algorithm possible. So for example, for HTTPS requests, commonly these days it would range from TLS 1.0 to 1.2. You really should be avoiding 1.0 if possible and preferring the stronger algorithms.
Okay.
And then the final thing I'll say about cloud security is just to prepare for security events, create a process and to respond to and mitigate the potential impact of security incidents following best practices, and most importantly, practice these processes before they need to be used for real. I think this is common saying that if you haven't tried to restore your database backups, do you really have backups? That principle not only applies to backups, but it applies to security processes as well. So enable traceability at all levels within your system, and make sure that you know how to access those things and know how to apply them when a security event occurs.
And I'm sure it's applying those same principles to the backups that you have as well.
Exactly, yes.
That's great. Ray, any other thoughts, any other ways that you build IoT security into device development?
Absolutely. From the device perspective, there's another list of things you want to consider that all play into the things that Michael talked about. When you're talking about creating an IoT device for security, you want to start with a process for identifying the data that's going to be stored on the device or processed on the device, because a lot of that information is going to be personally identifiable to the user. So you have a process for identifying that data and figuring out how the data is going to get from the device to the cloud and any other intermediary points in between. If your device is talking to other devices on the home network, you want to identify those things as well. And you build up a list of requirements for how do I secure each of those bits of data, and how do I secure access to my device, and then how do I secure my device's access to my home network. So you're really looking closely at every path of potential communication and looking at how do I best lock that down and secure it. How do I encrypt all of that communication? You also want to look at how your data is stored at rest when it's not being used. You don't want someone to access your light bulb or your toaster or your refrigerator and plug into it and hide some sort of connection to it and then be able to access everything while you're sleeping. So if the information on your device is also encrypted and signed, then you can be relatively sure that what's on your device hasn't been modified by some nefarious actor. Signing is a way to essentially identify who created what's running on your device and say, this person is authorized to actually give me this information or to load this device with what's running on it. And then encrypting is, again, a way to make sure that whatever's there isn't just available for anyone else to see and sort of break down.
That's really great, yeah. What about passwords? I hear all this like zero passwords. Are there ways that IoT is moving towards not having passwords, or just maybe more of that certificate signing and authorizing the device itself?
Absolutely. With passwords, really the biggest problem we have with them is people use them to interact with locking down the device. And that element right there, people have to try to remember passwords for every single service, every single device.
That's right. I forget my passwords all the time.
So it really makes for a scenario where people want to use passwords that are easy to remember. And if passwords are easy to remember, they're easy to guess. And if they're easy to guess, they aren't really locking people out who shouldn't be in there. So what a device will do instead is, instead of using a password to gain access, what's often used is a certificate that identifies that device. And that certificate is backed by a private key. And that private key is sufficiently locked down away so that no one else really knows what the contents of that key is. And then the device can use this certificate and say, based on my key, this certificate says who I am. You don't need to know my private key. Here's the public key that goes with it. This public key ensures that everything coming from my private key is attached to my identity.
That's really great. Hopefully we can get rid of our passwords. That would be awesome. Any other thoughts on that, Greg?
Ray, I do have a question for you. What happens, Michael described kind of having a process in place for if a vulnerability is found. What do we do on the embedded side if there's a vulnerability found?
If there's a vulnerability found, hopefully your device has been architected in such a way that you can have a secure chain of releasing new firmware, so that when you have that security update, as you mentioned earlier, the device manufacturer can craft an update that identifies and mitigates the vulnerability that was newly found, and then signs that new firmware update and then delivers it to the device since it's connected to the internet. And then that update process validates that this new update is legitimate and that it's encrypted and that the device is really the only thing that can unpack it and store it away and restart the device running the new firmware.
So it's really building it into all different levels, where Michael, you were saying you're building it even data at rest and then in motion, and then also responding to those events too.
Absolutely.
That's really good.
And another thing is, you also want to look at making sure that that update mechanism can't be used against you by rolling back to an old version of firmware. That's something that has to be part of that process, making sure that you can't roll back.
So you're almost forcing the update?
Once the update has taken place, you're making sure that they can't go backward.
Yeah, because if you know of a vulnerability in a previous version, then you could send the device an older version of the vulnerable firmware. It's legitimate firmware. It's signed, it's encrypted. From the device perspective, it's completely valid. But if we allow them to install it, then they install the vulnerable firmware and then you can exploit it.
Lots of things to keep in mind, and you mentioned that just even keeping the idea of personal identifiable information as well. We were talking a few weeks ago with a medical team, and they were talking about how you have to secure baby monitors and those types of devices, and you get into all that type of information. It's really important to keep your information safe in the IoT world.
Absolutely.
Well, thanks Ray, Greg, and Michael for participating in this discussion and keeping us informed about IoT device security. Any final thoughts as we close out this discussion?
Yeah, so from my perspective, tip number one is don't let security be an afterthought. I think when you're designing products, especially connected products that have a physical component, a thing, and the cloud side, you can't let the security aspects of it come at the very end. To what Ray was talking about with pushing over-the-air updates for firmware, if you don't design that from the beginning, then it's going to be very difficult to add that into the product once it's already in the field. If you let it go for too long, then it's going to be very difficult without recalling your devices or just recognizing that those devices are always going to be vulnerable. Tip number two is designing with security in mind is going to take longer than not doing the secure development. We want to make sure that you need to have those things in your product and recognize that sometimes designing it the right way is going to take longer than taking shortcuts. But those upfront costs are always going to be worth it rather than kind of a potential loss of reputation if your device is on the news next because you didn't have it very well secured.
No, we've definitely seen lots of those stories.
Absolutely.
Well, thank you, everyone. It's important to choose a partner that understands how to protect your data in IoT systems. Our IoT team is working hard every day to build IoT networks that are cyber safe. The next episode, we're going to cover some of those IoT stories in the news. For now, stay cyber safe.